Today, I want us to create this cam follower assembly mechanism in Creo Parametric, and we're going to see how we can create this simulation in Creo Parametric. Therefore, let me just close this, close. I'm just going to delete all these parts so that I can demonstrate how you can create an assembly, but these are the parts already existing. Let me see the parts. Okay. Okay, we have three parts. This one is a support. We have a follower, and we have the cylindrical cam. Let's start with this part. I will just go back and illustrate how you can draft this. First of all, you need this sketch, or create a sketch on any plane. The plane doesn't matter. Then let me show the sketch. Extrude your sketch using 160 length, like that. Then on the middle plane, either front or top, depending, just select the top. On the top plane, create this sketch here. Basically, I want to select a plane that is the middle of the part. Just create this curve. You can see I've used a 3-point like this, from here to here, like this. Yeah, these are 3-point arc curves, and make sure you connect them. You can see we have now that sketch. If you want to see the sketch, you have to ensure that you are in a wireframe, or you can use hidden lines option, and you can see the curve here. Yeah, if you select the wireframe option here, not the curve, then ensure that then you have to project this curve to the surface. Just select projection. For the curve here, you have to select to a curve. You have to go back to the wireframe and select to a curve like that. You can see here and say okay. You project this curve, you should see this. Therefore, if you go back to the shaded, you can see now the new curve here after projecting. Basically, ensure that you select all this outer surface here on the surfaces. Then the direction, depending on the plane you have used to design your curve. For me, I used right plane. The plane you used to design this sketch to, if you use a right plane, you have to use that as your direction, because for me this sketch exists on the top plane, on the front. Let's see here, you can see on the right. Let's see, you can see the plane here is on the right plane. Then select sweep, select your curve. What you do here is, let me go back and let me show this. That's activate. So select your curve here and go to model and select sweep. Then you can sketch, then sketch a circle there. Just go normal at this point, sketch a circle. Yeah, just sketch. If you say okay, it will automatically sweep and select remove material like that. You can see I don't need it. Let me just show you the dimension I have used. On the sweep here, edit. If you go to sketch here, I used 15. You can say I used 15. Yes. Cancel. Yes. I don't. Yeah. Lastly, can add some round fillets there. Extrude. Ensure create a hole here. Let's see this one here. You can see I have extruded a hole of depth 10. Let's see the sketch here of sketch of 24. sketch of 24. Then I made some small extrudes on this side to assist in visualization once we start animation. Okay, and we can insert, you can assign this appearance by going to view, go to appearance, oops, go to view, select the appearance you want, then the body like that, then say okay. Yeah, that's how you assign appearance. That one is a cylindrical cam. Then go to the follower. Let's first go to the support, then support again. Let me go back here. This is a sketch you need to draft on the front plane. Any plane can work still. 210 by 118, and we have a fillet here of 20. I'm using a fillet of 20 like that. Then sweep, select this one. Let's see, and the sweep here, go to sketch. You can see what I'm using. Sweeping is 10 by 20. Sweep a triangle of 10 by 20 like that. Okay, then on this face here, select and sketch to extrude. Yeah, let's see this extrusion here. Let's see the sketch. You can see the sketch I'm using. From this here to 5, from here to here is 5, length of 170. This one don't dimension. It is, this one is a center rectangle with these dimensions. That's fine. Last three on this face here, extrude this extrusion here, 15, sketch of 24. I'm using 15 and 20, but the sketch is 24. This one is let me go back to the cam. It will be assembled in this hole. The reason why this hole is also 24. You can see diameter of 24. Lastly, our follower. Let me go back here. Oh, this is our sketch here, and so we have this sketch of 10 by 10, 10 by 10 like that. Then you go to the extrude here, extrude it by, let's see, by how much, by 100, extrude by 100 like that. Then I need another sketch on the middle plane. You can see the middle plane. This is an arc of 7.5. Ensure the center of this line at this point they are coincident or 0 dimension. Then revolve this one. Lastly, we need a datum point. This point here, let me go to, if you select this surface like that, you can see your point can lie on any place on this surface, but for me I want it to be at the center. You can still use an offset if you want, like that, to offset from the center, but use at the center like that. Ensure this point is at the center. You can also rename the point. You can say central point like that. Okay, and if you want to see the point, you can activate here and see. You can see now the point is visible. Okay, if you go now to the assembly, we can assemble. Let's assemble the support first. You can preview. Here, support, assemble the support, open. For the constraint type, let's use default to ensure that it's central. As you can see, the origin is similar to the one of the actual part. You can see this origin here. Assemble again. Let's add cylindrical cam. Basically we want our cam to be rotating onto this surface. Hence, for us to achieve the rotation motion, we need to use pin connection. Connection is pin. Pin allows rotation without translation, without movement along any axis, just rotation. If you want movement, you select slider. If you want combination of rotation and movement, that is translation, you select cylinder. For now, we are going to focus on pin. In the pin, you select the surface that is going to rotate with respect to this surface. Again, you need to select the surface onto which we are going to be touching. This surface should touch this surface here, and you flip, then say okay. Okay, those are enough. If you select drag here, let's see whether it will rotate. This one here, you can see it is rotating because I've used pin connection. It doesn't move laterally, it only exhibits a rotary motion. Okay, and next we need now to insert assemble our follower. Open. Then the follower is supposed to follow this path. Okay, for us to follow a defined path is when you use a slot. Slot enables you to follow a certain path. In this path, we are going to select our point to follow this path that is defined by the curve. Therefore, for the assembly item, just select this one and press Ctrl. Ensure you select everything on this arc. Select everything like that. 4 items, or depending on your curve, you might get 4 items, 2 items, or 1 item, but ensure you select everything. But for the component here, you select this point, the point that we defined. Remember the central point we defined? You select that point and you say okay. What happens when you do that? This follower is going to follow this curve. Let's see what happens when you move it. You can see it is trying to follow, but it is rotating. You can see this rotation. The slot doesn't prevent component from rotating, but it allows you to follow that path there. Now for us now to ensure that this is not happening, I will have to ensure that this surface and this surface are coincident. Let's first of all check the measurement. If you measure here, we are getting 10. If you measure here, I'm getting 10. Meaning what? Meaning this surface here and this surface, we can make them coincident. You go back to the follower, go to the connection, then new set here, select a new set. This one was a slot, can see connection, but here we're going to use a new set and call it, we're going to use general. General allows you to define extra constraints in existing constraints. For now, I want to use a general constraint that is automatic, detect what I need. I want this plane to always be coincident to this plane. You can see now we have coincident. This is our coincident, can see that from top view. Then if I say okay, let's see what happens again. Now you can see now it is not rotating, but it is moving like this. For us to prevent this movement, what we do is we ensure this surface and this surface remains parallel. Don't make them coincident, otherwise it will not move. Go to this one here. On this here, general, another coincident of this one here to this, but not coincident, we said parallel, like that. You can see it is parallel. If you now try to move this, you can see now it is moving without rotating. Move again. You can see, yeah, that is what we need in this mechanism. Next, you go to applications and select mechanism, and we just need to define this one to rotate. We can define this also, or this. We can also define this slot, this to move, but the easiest one is to define this rotation here using a motor. Therefore, if you select servo motor, select this here. For the profile, I'm going to use angular velocity. I want to use 30 degrees per second. These are the driven quantity. You can have angular position, angular velocity, angular acceleration, and torque in case you want to perform some dynamic analysis. But for me, I want to perform kinematic analysis, hence I don't need force or torque to be applied in my model. Therefore, angular velocity is enough. These are the types of the function. Motor function. You can have constant, you can have a ramp function, cosine, cycloidal, parabolic. If you select, for example, parabolic, you just define a and b, then it will generate a parabolic profile for you. For now, let's go with a constant of 30. And a graph, I want to have velocity. If you want graph, you can select velocity here, and you can define your motor. Maybe I can say this one is maybe rotary rotation motion. You can have, the reason why we define the name of a motor is you can have maybe about 6 motors in one mechanism, and you want to select a specific motor, therefore like that. Next, if you go to the mechanism analysis, I want to use kinematic. Remember I said for the dynamic is when you need some forces to be applicable, but for now I want to use kinematic. Start time, I want to use 10 seconds is fine. Frame of 20, that's fine. And for the initial conditions, I want to leave them as default here, unless you have a snapshot. You can run like that. If you say okay, if you go to the playback and you play, if you see, let's high speed, let's play. Okay, you can see simulation here. Let me first close this one like that. Maybe let me move this one here somewhere there. Assuming I want my analysis to start from at that point, you can create what we call a snapshot and select here snapshot and call it start. Close. Therefore, in case I move my part like that, then close, I can go to the snapshot here, drag component, this one here, and can say display. You can see, even if you move it around like this, you can always go back to this one here and display to go back to that point. And if I go back to the mechanism, let's go to analysis. You can get analysis here. Let's delete this one here. Edit. Now, as you can see, for the start, I had selected current. This is the current. Current is where it was all the way back. But for now, let me first go back. Maybe you can say stay there. If I go back here, you can see for the initial, when I select current, it will start at this point and start analysis. But when you select snapshot, I can select my start here. You can also preview your start. You can see it will start from there and run. Yes, overwrite. Therefore, you can always select where you want your analysis to start during analysis. And if I go to the playback, you can see now it moves to that point, and it will always start at that point because I've defined that as my snapshot. can say play, can increase the speed there like that. Yeah, okay. If I go back, let me go back to the motors here. This motor, let's edit. Remember, I had defined as a constant. You can also define as a ramp. You can say maybe coefficient. Let me use 30, then 90, like that. Okay, let's go back again here. Let's go to profile. Yeah, okay. I'm using that and 90. Let's see the graph here. This is the graph of the velocity against time. Okay, let's first just close it. Okay, let's now go back to our analysis here and select run. Okay, let's see what happens. You can see it starts with a small value, then increases to 90. Therefore, if I go to the playback, play, it will start from because is a ramp, start from 30, then goes, it increases up to 90. Start slowly, it will start to accelerate ramp like a ramp motion. You can see it is just calculating. Let me just, you can see it starts slowly, accelerates. Yeah, because that one is a ramp. Okay, that's how you can use you can just cross here and save like that. That's how you can use this type of connection here, slot and pin, with a general to perform this type of analysis. Thank you and stay tuned for more.